And here we have installed the Asymod Mini. We've also installed a switch to turn the amplifier, the PA, on and off. We've now finished the installation, and in the back we've installed our high and low power switch, our amp keyer, and our line in. So we'll go ahead and key up on low power. We've set it for a 2-watt dead key on the 50-watt slug. We are right on 27205. Let's run an 800 hertz tone. We have a 50 megahertz span, so let's put our span to 60 megahertz. And we can now see the second harmonic on 54 megahertz right there. And we'll set a reference there, 2 divisions. We run the tone again. We're doing about negative 99% peaks, and 100% should be right here. We're about 160% modulation. And everything looks fine on the spectrum. We only have the fundamental frequency and our harmonic at 54. Here we have Chuck's DARP EX, Ranger RCI 2995 DXCF with the Asymod 7 and the DARP EX package. Again, here in the DARP EX, you have your demodulator, your Asymod, your recorder playback, and your high and low RF power control. The demodulator allows you to listen to yourself exactly as you come out of the RF stage into the antenna. It's like having a radio listening to your transmission, but built into this radio. This simplifies your setup when trying to monitor your station, to do your settings and tuning in your audio process chain. Your Asymod gives you the wide bandwidth hi-fi audio and the asymmetrical functionality to make you sound louder without distortion by increasing your positive peaks and maintaining your negative peaks at 99%. The Asymod DARP EX has the built-in recorder, and here you have the Asymod hi-fi recorder playback device. Your Asymod 7. This radio includes the display filter, which is right here. Takes the noise from the display out of your audio. Also, we've installed a 10,000 microfarad capacitor as your main filter capacitor to clean up your DC a little bit more. You have all the necessary hi-fi mods to enable the front jack while on TX, so you can monitor yourself using the demodulator. And here in the rear panel, you have your RF sampler output. You have your amp keyer, your TX and RX record output, so you can record your transmitted and received audio on an external device. Your line-in connector, your Asymod enable and disable switch, which reverts your radio back 100% to factory specs, and your VFO whine switch, which allows you to turn on the heterodyne effect on or off, causing the VFO whine effect. Here we have the RCI 2970 N4, and we've installed the Asymod standalone unit and the demodulator that we haven't done before on this radio. We put the demodulator here in the back with the tone and volume controls. Get your high-low power, demod volume, demod tone underneath. There's the demod output. All the mods have been done for the speaker disable while on TX, and audio amplifier enable while TX. And here in the back, we have our demodulator audio output, your volume control, your tone control, and your high and low power switch. Here on the Asymod unit, you have your line-in connector, your ground, your amp keyer, your PTT, and your transceiver connection for the HDMI cable. Here we have James IC 7300, and we just installed the Asymod 6 in it. The new look of the Asymod IC 7300, Hi-Fi, asymmetrical AM, and ESSB transceiver. So let's give it a little test now on AM. Let's bring our carrier all the way down. And at this point, we have to set the RF power on 50% when running AM and the Asymod. Again, we have the Asymod enable disable switch in the back. Right now it's in the enabled position. The 1/4-inch jack is connected to the output of the audio processor. And we just keyed up at the minimum carrier at 50% of RF power. And we see 1 watt on the bird. If you want less than 1 watt, you can bring it down over here on the main RF power of the radio to anything in between 0 and 1 watt. But it's recommended to write it at 50% of RF power and start off at 1 watt and go up as you need. So there it is, there's the reference at 1 watt. Let's go ahead and start the SIGGEN. Key up. And there we have our modulation envelope. Let's bring up the modulation a little bit. Right there, we see our 4 watts PEP. If we bring up our asymmetry, this button here, your PEP power goes up, as well as in the scope, up to 300%, as you saw there. But that's a nice setting right there, 150%. So that's the Icom IC 7300, and then new low profile knobs mounted on the top cover. Here we have Hutch's DARP EX. We just finished working on it. Now we're gonna go ahead and run all the tests to make sure it's working fine. So you have the DARP setup plus the EX, which has all the extras in the back. Here we have our demodulator output, our amp keyer, our TX RX record, and your line-in connector. Over here you have the Asymod enable disable switch and your VFO wine right there. So we'll go ahead and test it out, make sure it works okay, and go work on the Stryker SR-955 V2 that he's also getting. So we'll be done soon, and we'll check that out. And here we have finished Jesse's 2995. And we've installed the Asymod 7 in it. There's the dart built. In this particular build, the radio came with a reverb board installed, and it was installed on this side of the radio. So we had to kind of like move everything around to this side and mount it there, so we can mount the Asymod there. We've done all the mods that we normally do, including the filter for the noise created by the display. Changed the cap, filter cap on the board. We've removed all the cables for the amp or the PA relay. It goes from here to the PA and routed it to the high-low power switch in the front. And you have your amp key here, your line-in connector, and your VFO wind there in the back. We'll take a look at that. And you have your recorder there on the side for your record playback function. We have there our padding resistors, our demodulator, and our audio circuits. We've mounted the speaker in the bottom panel so we could free up space for the front panel controls. So there it is. RCI 2995 DXCF DARP built. Today we say farewell to the Stryker SR-955 HP V1. And it'll probably be the last time we install the Asymod inside the Stryker V1 right out of the box. And here we have the V1 on the left and the V2 on the right. Can you tell the difference? Nope, not at all. Only the little ridges here on the cover. Folks have been asking if there's any difference between the V1 and the V2 as far as hi-fi AM. And we'll try to find any difference if there's any. And here we have both V1 and V2s completed. Both builds have the amp here option installed. So now we'll go ahead and give it a little test run. See how it works out. So here we have the V1 set up, and we're going to be, in this case, running the SIGGEN and Pro Tools to do the tests instead of our standard SIGGEN over here. We will key up using this switch here. And this, for this build, 4 watts of carrier was requested on a 50 watt slug. There's a little bit above 4 watts at a time. So we'll go ahead and trim it back right to 4 watts here on our carrier control. And over here we're showing a little less power, 3.5, due to the loss in our wiring. And the different couplers that we have in line. 2049 here. We will have to trim our frequency a little bit. Got our trusty tuning tool here, and we're going to bring it up to, there you go, 27.205.001. It's pretty good. All right, so we have our reference set here in our oscilloscope of 2 divisions. It's been requested to set it at 150% modulation, and right there we are at 150. A little more, 150, and a little bit more. The Stryker SR-955 HP V1 is now discontinued, and we're moving on to the V2 now and getting a look at it. So now we've switched places here, and now we have the V2 on. And we'll go ahead and key it up. And this one's been set for a 2-watt dead key. Trim it down a little bit there. Right on. Again, here we have a little less because of the couplers and a little bit of loss that we have in all the wiring for the test equipment. We gotta adjust our scope here. This V2 comes factory perfectly on frequency 27.205.02. It's pretty close. So it goes to show you that the new ones, they come right on frequency, the V2s, versus the V1s, we always have to tweak it, put it back on frequency out of the box. I'm here to the scope, and this one's been set for 200% modulation. We're just a little over, so we'll trim down our asymmetry control just a little bit until we hit 200% right there. 200. That's 300. But we're going to put it at 200 right there. And we have a 18-watt PEP from a 2-watt dead key. So basically there's no difference in performance. The audio response is the same. We're feeding directly to the finals, so there's no obstruction of or limitation or filtering of the audio frequencies. We're going straight audio processing into the Asymod to the finals. We'll now test the bandwidth on sideband. We'll go ahead and key up the radio. And we have the signal generator set to 10 hertz. 10 hertz right there. And we'll gradually go up, and it will go all the way up to 4.3 or 4.4 kilohertz of bandwidth. That puts us on ESSB, I believe, class 3. So we'll look at the scope response as we go up in frequency. That's 10 hertz. It's 24 hertz. So we start getting a response above 40 hertz. That's 62 hertz. Try to get them both on the screen. We'll go up to, we're already doing full power at 60 hertz. And we'll continue to go up. We'll go one significant digit up. Let's round it off to 0 on the second digit. Go back up to the significant digit. And we're coming up to 100 hertz. That's 400 hertz. We'll go to the most significant digit and go 500 hertz. That's 1000 hertz. And we'll skip to 4000. That's 3000. 3200. That's 4000 hertz. We still have full amplitude of power. We're transmitting the full 4 kilohertz power. So here we are at 4 kilohertz. We're still doing full power output. At 4 kilohertz, we'll go up 4.1 kilohertz, full power, 4.2, 4.3, 4.4, 4.5 kilohertz, 4.6, 4.7, 4.8 kilohertz. We're almost 5 kilohertz wide, and we're still doing almost full power. So this is where we start rolling off. We'll go to 4.9 kilohertz. Now that's 5 kilohertz, as you can see there. 5.0 kilohertz. And then when we go to 5.1, we make a major drop in power. that is 5.2 kilohertz, and 5.3 we roll off completely. So our bandwidth here is 5.3 kilohertz of audio on sideband. We're looking at John's radios. He's got two of them, the actual RCI 2995DX, and then he's got the 2995DX CF that we'll check out later. He sent this one because he said that the radio had a delay when the processor is on. Obviously, audio processing, if you're using computer-based audio processing, there's going to be latency unless you use rack mount equipment, so we'll rule that out. Everything's working fine. There is no delay on the radio itself. Noise toy and replaced with VFO wind-up. The radio already had the wind-up, and we removed the noise toy. Now, as far as the wind-up, this is how it works. You go to AM, and let's go on low power. High power. And the VFO wind has been turned on in the back. When you key up, you look at the spectrum analyzer. That will start off the center frequency of the channel 27.025, which channel 20 is right where that arrow is. The red arrow. Alright. When we key up, the carrier will start off a few kcs down, and within 2 or 3 seconds, it'll move to the center frequency. Okay, so as we key up, see the carrier on the left, it moves to the center. That is the VFO wind. There's a heterodyne effect. So the key up starts on the left and moves into the center channel right there. So that's working fine. To hear it, you put your radio on sideband, your receiver, in this case, upper. You key up. We'll start off with the center frequency of channel 20, which is 27.205. And as we transmit, we'll start off on the left. Our carrier will start off on the left and will move into the fundamental center frequency within a few seconds. And that's what creates a heterodyne effect. Now we're in sideband mode to test out the power output. Our scale is on the top. That is 200 watts, and the last line there is 250 watts. So when we key up, we're doing about 225 watts. The older 2995s with the 2SC2290 transistors generate a lot more power output than the new ones with the FETs. Here's the other radio from John. It's the newer style RCI 2995DX CF. Now these have a different PA unit, and they produce less power than the previous older model. As you can see here on sideband, we're again in the 250 watt slug. And when we key up, we got 150 watts. We got 150 watts maximum. This one's a little off, but the bird says 150 and a little more. Okay? So that's all you're gonna get out of this radio. It won't do any more than that. Here we have a stock Cobra 29 LTD Classic, and we're about to put the Asymod 7 in it. Right now it's totally stock out of the box. We're gonna run it with the static 575 M6, and that's our it shows 3.5 watt carrier swung into about 10 watts. Audio 1, 2, audio, and audio 1, 2. We see a lot of flat lining there, the 0 volt line. Here we have Jay's Cobra 29, and we installed the Asymod 7 in it with dual DC to DC converters to have 10 amps, since the Cobra only has a 2-stage final, and it takes a lot more to drive it than regular other radios such as Galaxies, RCIs, and so on. So this radio can't go very high. The headroom is not that much, so it's maximum 2 watts of dead key, and you'll still be able to get about 200% modulation, or 250. At 1 watt, you'll be able to get to like 275. Oh, let's go ahead and key down. Let's get our tuning tool here. Killer SIGGEN there. And now we'll go ahead and key up with a regular mic here. And we have 2 watts on the bird. We'll bring that down to 1 watt. Put it at 1 watt right there. We'll set our reference here. We'll run the SIGGEN. Run the SIGGEN. Now we're a little hot there, so we're gonna have to bring down the asymmetry. I'm sorry, we're a little hot there, so we'll have to bring down the modulation right about there. The asymmetry is up at the moment, so let's put it down. And as you can see, that's our 100% modulation right there. And as we raise up the asymmetry at a 1 watt dead key, we can get to about 250% modulation. About 10 watts, PEP. Let's kill the SIGGEN again. Let's put our carrier up to 2 watts now. Adjust our oscope. Start the signal generator. And you can see we have some clipping going on, so we have to back down our modulation. Take out our asymmetry completely. Bring up our modulation. That's our 100%. And the 2 watts, the most that we can go is to 175 positive modulation before we start clipping, and that'll bring us to our 10 watts PEP from a 2 watt carrier. Hey folks, here we have Derek's Cobra 29LX, I think LXBT, with the Asymod 3. Wow, I haven't seen this in a while. This is one of the first Cobras that were done with the Asymod 3 various years ago. And we're going to go ahead and swap it out with the Asymod 7. And now we're going to use the front panel potentiometers for the controls. Asymmetry, modulation, and carrier. As you can see, we have the connector running to the pots. And whatever pot we used, we replaced with a small potentiometer, so the adjustments can still be done inside, although we took over the potentiometers in the front panel. All the controls will still be inside. This is, for example, for the talkback. This is for the a delta tune right here. We're going to install a potentiometer for that now. And we're going to go ahead and install the carrier where the dynamic is right there. Cool. Okay, here we have the Cobra 29, and it had the Asymod 3 in it, and we upgraded it to the Asymod 7. We put the power transistor over here in the back, the modulator transistor. We used the front panel controls where your talkback right here is your carrier, your delta tune is your modulation, and your asymmetry is your dynamic. Okay, now the dynamic has been moved to here in case you need to adjust it. The delta tune has been moved to here. Okay, the only thing that has been disabled and doesn't really work is the SWR calibration. Okay, so actually, yeah, we used the talkback, which is this one, for your carrier. So the talkback could still be done with this back here because they were in parallel. Okay, I don't know why they have the SWR and the talkback. They were jumped together, and there also it's also on the circuit, as you can see here. Over there, you can see where these two talkback and SWR calibration, they're parallel. They're both doing the same function. So anyways, that's that. And now to transmit, we are transmitting already. We're on TX. So basically what we'll do is race up the carrier and we'll look at the bird. And as we race up the carrier, we can max out at 4 watts. Right here, you can see as I turn it. See if I get it to focus on both. See it rise. So if we put it at 1 watt, or we go here to the LP700, and whatever. Okay, so we'll go by that one. We'll put it at 1 watt, and we'll modulate. We'll put the SIGGEN here. We're at 800 hertz, 215 millivolts peak to peak. So we'll go with that output. First of all, let's calibrate our scope. Let's put it at, that's 2 divisions right there. And start modulating. Okay, so that's that. We have the spectrum. Now here we can raise up the modulation or lower it down. You can see over there in the scope, that's too much. So right there is perfect. And then your asymmetry is here. You can see your asymmetry rise and fall there on the scope. That's 100, and it goes up to about 200% right there. And on the bird, or you can see here, modulating at no asymmetry is 4.4 watts, and with full asymmetry you got 10 watts. No asymmetry, full asymmetry at 200%. Okay. The VFO wine effect. And here we have the potentiometers already connected. the front panel potentiometers leading up to the connector. The JST connector is going to go into the Asymod 7, right there in J1. Okay, here we have the Cobra 29 LXBT, I believe. Welcome to another Asymod video. Here we have the Galaxy DX959, and we just installed the Asymod 7 in it, and we're going to give it a little test. Got some folks asking about sideband bandwidth. We're going to go into that and take a look at it. In this case, we're running the Asymod directly into the balanced modulator, and we'll see our bandwidth would increase from 3 kilohertz to almost 5 kilohertz. That'll bring us to ESSB medium 2, which is right about 4.7 kilohertz. Right there. That's 50 hertz through 4.55 kilohertz. Right now this is ESSB. So our audio is coming into the Asymod when it's on sideband. The Asymod AM side turns on and the sideband side turns on, and we feed the audio directly to the balanced modulator. It gives us about 4.9 kilohertz of audio bandwidth, so that's obviously already well into the ESSB domain. So the question here is, how far out ESSB do we get out as far as bandwidth? Well, we'll start off at 1,000 hertz, 1 kilohertz, and that's our signal generator right there, 1,000 hertz. And our fundamental, of course, is going to be 27205. If we go here on AM mode and we transmit, we'll be using this little switch here. We'll see our center frequency is at 27205.001 on AM. And there's our carrier, unmodulated carrier. If we were to modulate that carrier right now, we're at a span of 30 kilohertz. Bring up the modulation until we see there negative 99 modulation. And at the moment we're doing 150%. That's our modulated carrier. And at 1,000 hertz. Let's go ahead and switch over to upper sideband, and we'll go ahead and transmit. And as we can see, now we are at 27,206. That's the fundamental, which is 27,205, plus our 1,000 hertz of audio right there. Brings us to 27,206. Now, as we increase our audio frequency, let's go ahead and put 2,000 hertz. now we're at 27.207. So we've increased another 1,000 hertz in our signal, and we still have a very decent signal. So this is our 2 kilohertz audio tone out of our fundamental 27.205, and it brings us to 27.207. 205 plus 2,000 hertz will bring us to 27.207. All right, and we can see that here in the oscilloscope as well. We're at 27.207. Now, let's go ahead and put 3 kilohertz of audio, which is the standard factory. Let's stop transmitting and adjust this to 3 kilohertz. Now we have 3,000 hertz, 3 kilohertz. And we'll go ahead and transmit. And now we look at our signal, and you can see we haven't lost any power. And we are at 27.208 on the spectrum. And we are 27.208 on our oscilloscope. And also here at our frequency counter. All right, so let's go ahead and go to 4 kilohertz of audio. We've set our signal generator for 4,000 hertz, 4 kilohertz, and we'll go ahead and transmit. And when we look at our spectrum analyzer, we could see that we have now 27.209. That's where our peak is at, and that's 27.205 plus 4 kilohertz brings us to 27.209, and our oscilloscope is also in agreement, and also our universal counter 27.209. So for lower sideband, it's going to be exactly the opposite. We're going to be counting down 1,000 kilohertz at a time, but let's take it one step further and find out what our limit is for ESSB. We'll stop transmitting and increase this to 4,700 hertz, 4,700. All right, so there we are. And now we'll go ahead and transmit. And we still got plenty of power on the meter. We have, our amplitude is still the same. We haven't lost any power in our signal. And as we can see, we're at 27.209.7. That's our 4,700 hertz audio signal. That's bringing us up to 27.209.7, just as seen here on the spectrum analyzer, 27.209.7. So right now our bandwidth on sideband is 4.7 kilohertz wide. So let's see how far up we can go. Let's go back to our generator and let's put it at 4,900 hertz, 4.9 kilohertz. And as you can see, at this point, we're starting to lose a little power. We're about 5 dB down at our peak. And now we're at 27.209.9. That's almost 5 kilohertz of audio. So there you go. We're very close to 5 kilohertz of audio on sideband. So in conclusion, we see that we are at almost 5 kilohertz. So we're very close to ESSB wide 1. Okay, we're well into 4.5 kilohertz, so that's ESSB medium 2, and we're scratching a 4.9 kilohertz, so we're almost at ESSB wide 1 there. All right, so I hope you enjoyed the video regarding this. I've had a lot of questions regarding ESSB and if these radios really do ESSB, so there you have it. Well, finally, we're gonna set it to what the customer wanted it to, which was for a 1.25 dead key. So we're gonna do that by turning off the SIGGEN here. We're gonna key up using our little switch, and we have it set to 1.25 watts there. And we'll go ahead and start the signal, the audio signal, and there we have it. We have about 150% modulation right there on the asymmetry. Go a little louder. That's 200. We'll leave it around 150, and that'll put us at 8 watts PEP. We're on the 50 watt scale there, so 50, that's 10 minus 2 lines, puts us at 8 watts. So you shouldn't see more than 8 watts when you speak into the mic. If you do, back down your audio. You don't want to go above 8 watts PEP. Here we have a new Stryker SR-955 HPC, and we have just installed the Asymod 7 in it. This is the version 2. In the rear, you have your line-in connector, your PTT connector, your amp keyer, your external speaker, your CW keyer, and your USB connector. With Asymod 7 installed, we don't have to worry about any of the adjustments for AM. All the adjustments you need are right here. The Asymod gives you 15 kilohertz of bandwidth to be rolled off at your preference via the audio process chain, and also has a wideband audio output for your ESSB. And the Asymod gives you the asymmetrical control, which allows you to sound louder without distorting. With the Asymod installed in this radio, we actually bypass all the digital controls and filters, and we go direct analog to the finals. So whatever you put in is what you get out. You can find the Asymod Ready SR-955 V2s at asymod.am or on eBay. Hello and welcome to another Asymod video. Today we're going to be working on the FTDX 3000, and we're going to go ahead and install the Asymod 7 in it. The FTDX 3000 is a great radio. However, AM is not all the best, but we're going to go ahead and change that. Here we have the FTDX 3000, and we just installed the Asymod standalone. The Asymod standalone connects to the FTDX 3000 via this HDMI connector right here in the back. And you have your line in, your ground, your amp keyer, and your PTT. In the back of the FTDX 3000, you have your HDMI connector and your Asymod bypass switch or Asymod enable disable switch. The FTDX 3000 doesn't perform that well on AM as it comes from factory. So with the help of the Asymod, we turn this into an AM beast. So we'll go ahead and give it a test run, see how it performs. Make sure your RF power is all the way up to 100 watts all the time. The Asymod will be controlling the carrier, but we need to have that at 100 watts. Key up and set your dead key wherever you want it. Right now it's at 2 watts. You can set it anywhere. I don't recommend going above 10 watts. That's the maximum you should do. I always say the radio is just the exciter. If you want power, let the amplifier do the dirty work. We are at 29,300. All right, so we have a reference set. We'll go ahead and start a SIGGEN. And there we have our modulated envelope. Right there, we're doing a little bit above 100% modulation. If you're in crystal asymmetry, you're almost at 250 there, back down, close to 100. Your bandwidth is about 15 kilohertz. Of course, you got to roll that off with your audio process chain or your equalizer. Asymod gives you the loudness with the asymmetry control. So I don't recommend running this radio so it could have enough headroom. More than 5 watt carrier, you could run it at 10 watts, but I don't recommend doing above 100% modulation at 10 watt carrier. All right, so that's the FTDX 3000 and the Asymod standalone. To disable the Asymod and run the radio as it comes from factory, just unplug the Asymod and flip the switch off. You can leave the Asymod inline connected. However, when you are in sideband, your audio will go through the Asymod and straight into the radio. All right, moving on to the next radio. Hi, and welcome to another Asymod video. Here we have the Ranger RCI 99N2 with the Asymod standalone unit. This is a real nice looking radio. Does about 150 watts. Works very well with Asymod. Pretty much the same board as a 2970 N4, N2 series, N3 series. The RCI 99N2 asymmetrical hi-fi AM and ESSB transceiver. So just do a short test. We don't have time to do the full video. And we're gonna go ahead and key up and set it at 2 watt dead key. Right now the radio has a nice high and low power switch in the front, so we don't have to be doing that anymore. Putting the high and low power switch in the back. So it's in low power. We'll bring up the carrier to about 2 watts. We'll adjust our O-scope for 2 divisions. We'll start the SIGGEN. And there we have the modulation envelope starting to form. We'll bring up the modulation until we get to 100% modulation right there. Adjust the trigger a little bit here. And then we could add asymmetry right here to about 210% modulation. Positive modulation, that is. So there you have it. High power. As you can see, the meter has deflected all the way to past full scale. But we'll adjust the scope here to see. We'll unkey and we'll take off the SIGGEN and we'll set our reference There we go. Start a SIGGEN. If we raise up the modulation, we start to pinch, so we don't want to do that. We go right there where the troughs are nice and round. Give it some modulation. Okay, right there. That's your 100%. And high power. Right there is doing about 50, past 50 watts of PEP power. You can increase your asymmetry. As you can see, that's about your 50 watts. And once you increase your asymmetry, you go all the way up to 80 watts. Bring it back down. And there you go. Good looking radio, good working radio. I hope the owner enjoys it. All right, thanks for watching. Catch you in the next video. Here's Chris's FTDX 1200 with the Asymod 7 standalone unit. Normally these great units, such as the FTDX 1200, they don't perform that well in AM out of the box. So with the Asymod, we're able to transmit up to 15 kilohertz of bandwidth, and we have the asymmetry control that we're able to increase our positive modulation to sound louder without any distortion. We're able to set our carrier from 100 milliwatts all the way to 15 watts and still have enough headroom for 250% modulation. Setting up is easy, and it has an enable-disable switch in the rear where you can bypass the Asymod and use the radio as it comes from factory. For now, we're going to use the MOX switch, manual operating transmission, and we're going to key up on AM, and we'll go ahead and disable our tone generator. And look at the scope here, and we're going to increase our carrier over here, let's say to 5 watts. On the bird, we could see there, we're gonna go to 5 watts right there. And again, we go to our O-scope and make sure we have 2 divisions, 2 gradients as a reference to read our modulation envelope. And we start the signal generator now, and right there we have our 100% modulation. We're a little, we'll go a little higher in modulation here till we hit our negative 99%, right about there. At this point, we're about 110, 115% positive modulation, and you can increase that by raising your asymmetry. If we go ahead and raise our asymmetry, we can go up to 200% right there, all the way to 300%, and that puts us at about 75 watts. That's a 250 watt slug that will be 90 watts right there. That's 75. And that's 300% modulation. Of course, we don't want to be all the way up there. We want to be around 150, give or take. Just our trigger here a minute. And there's our modulated envelope at 150% modulation. Again, we can adjust that by raising our asymmetry. You go all the way to 300%, down to 100, from 100, 200, 300. The Hi-Fi asymmetrical AM and ESSB FTDX 1200 with the Asymod 7 standalone unit. Here's Jason 7300. We're putting the Asymod 7 internally. Here's Jason 7300, the IC 7300 from Icom. We're putting the Asymod 7 internally with the top panel controls right here, as you can see. And we're almost done. We already have all the jack in, the line-in jack, all the PDT, the Asymod disable enable switch, the amp key jack, almost all the connections. Now we're doing the RF switch for the final driver to switch between 13 volts and the modulated output from the Asymod board. Now we have almost all the cables into a harness to the Asymod board position, and soon we'll be installing the Asymod board on there. And here's our harness for the external pops on the top cover, connected to J2 of the Asymod board. By the way, instructions for the installation on the 7300 Yaesus like the FTDX 1200, they're all on the downloads link on the download tab on the Asymod site, asymod.am, www.asymod.am. Here we have the hole for the harness, for the potentiometer harness. And there we have our harness passed through. For our pots. And this will be for the modulator and 13 volts at the final stage. So we pretty much have all the cables already that we need installed. All we need to do is put the Asymod board in and connect the front panel and the potentiometers. So we finished running all the cables. Here we have the two J1 and J2. We have the audio and the rest of the wires all neatly next to where the Asymod is going to go. Now we've finished doing our cutouts so the Asymod board will sit properly. We shaved off a little bit here, here, and here. That way it sits nice and flush against the heatsink. Again, a lot of folks ask me, they want to install the Asymod board themselves, and the instructions to install the Asymod 7 inside the 7300, along other instructions for a lot of radios, are downloadable at the Asymod site under the downloads link, www.asymod.am. So everything's in now. We have the harness ready to be installed directly to the pots. J1, J2, power, amp key, everything is connected now. And we're ready to mount the front panel and the potentiometers. And here we've set up our PTT connection to the front mic jack. And this wire will go to this wire once we attach the front panel, which goes to the PTT connector right there in the back panel. And the potentiometers are installed in the top panel to the harness. And we've soldered our speaker back in there. We're ready to assemble the top panel. And there it is. Okay, we're ready to begin testing, and this unit is brand new out of the box. It was drop shipped from HRO, ham radio outlet. Most folks do that. So we have completed the installation, and we're ready to begin testing. If you would like to get an IC 7300 with the Asymod 7 installed, you can purchase a 7300 and HRO, ham radio outlet, and drop ship directly to us. And we'll install the Asymod 7 and ship it right back to you. Here we're looking at Jason's Icom IC 7300. And in the back panel, we have our amp key, Asymod enable disable switch. You can either bypass the Asymod or enable it. Your PTT switch and your line in connector that we've added to the back panel. On the top, we have our Asymod controls, carrier, modulation, and asymmetry. Okay, we'll go through the functions to show how the radio works. It's fairly simple. So let's begin. We'll test out the radio. We're going to have the line-in connector plugged in, so that means the audio from the front mic, if it was connected, will be disabled, but we'll be using the transmit button in the front panel rather than the PTT on the mic or the external PTT. We're just going to use the transmit button here. So make sure we're on AM, make sure we have the Asymod enabled in the rear panel, and we'll go ahead and transmit. We got to bring all the controls down before we do that. So transmit, and let's determine a dead key. And for this demo, we're going to go ahead and let's just set it at 3 watts right there. 3 watts. Okay, so it's fairly simple. Adjust your carrier, set your modulation, add some asymmetry. Sideband. When the Asymod is enabled, Your audio will be running through the Asymod and going directly to the digital analog converter. So we'll bypass any filters that the radio uses for its stock hand mic preamp. We'll bypass all that and go straight to the DA converter, allowing for a little more bandwidth. Anyhow, that's the Icom IC 7300 with the internal Asymod 7. Check us out on asymod.am, www.asymod.am. You can contact us. Let us know if you want to send in your Icom IC 7300 for the Asymod 7 upgrade, and we'll send you the details. All right, thanks for watching.